Hello students, today we will be solving the IB Math AHL May 2025 paper 1 time zone 2 question number 12. You will be getting the solutions for the first 11 questions of this paper and the solutions for the other questions from the other past papers in form of playlists on my channel NS Online Math Tutoring Classes. You will also be getting playlists where the solved past paper questions will be available based on their topics. I'm Nilanjana Sanyal. I am an online IB Math AHL level tutor. My phone number and my website address are displayed at the bottom of the screen. So without any further delay, let us start to solve the question number 12. The maximum mark is 19. Subpart A. Solve z square equal to negative 1 minus root 3I, giving your answers in the form of z equal to r times cos theta plus I sin theta. Okay, so we have to get the modulus and we have to get the argument. The modulus for z square will be is equal to negative 1 whole square plus minus root 3 whole square. Negative 1 whole square is 1 and minus root 3 whole square is 3. So 1 plus 3 is 4 and square root of 4 is 2. Okay. And for the argument of or tan of argument of z square will be equal to negative root 3 over negative 1, which is equal to root 3. Now, tan is positive in the first and the third quadrants. This is root 3. So, tan, we know that tan of 60 degrees or tan of pi over 3 is equal to root 3. But when we look at this complex number, we find if we have to plot this complex number on this argand plane, it will be on the third quadrant where the real part is negative and the imaginary part is also negative. So it will be placed on the third quadrant. Therefore, the argument will be, argument of z square is equal to pi plus pi over 3, which is equal to 4 pi over 3, but we write the argument in the form of negative pi to positive pi. Okay, so the third and the fourth quadrant angles are expressed as negative angles. So it is 4 pi over 3. That means maybe this is pi over 3 angle, 60 degree angle. So we have to express this 4 pi over 3 as a negative angle. What negative angle can we write in place of 4 pi over 3? See, the negative angles are formed by the clockwise revolution of the revolving ray. So I am moving this revolving ray to this part, to this axis, real axis. Since I have moved the revolving ray in the clockwise direction, so the angle formed is negative pi. And then I am moving the revolving ray in the anti-clockwise direction through an angle of pi over 3. Because I am moving in the anti-clockwise direction, this is a positive angle. So it is minus pi plus pi over 3, which is equal to negative 2 pi over 3. Okay. So therefore, I can write this is equal to negative 2 pi over 3. Okay. So therefore, Z square is equal to the modulus is 2 and cos negative 2 pi over 3 plus I sine negative 2 pi over 3. Okay. And now we have to take the square root using de Moivre's theorem. We have the first root will be equal to maybe Z1 equal to, we'll be taking the square root of 2, so it will be square root of 2, the modulus, and it will be, the angle will be negative 2 pi over 3 times half. So it will be cos negative pi over 3. Negative 2 pi over 3 multiplied by half is negative pi over 3 plus I sine negative pi over 3. Okay. And the second root, for the second root, we have to add the total angle around the central point, the origin is 2 pi and there are two roots. It is 2 pi over 2, which is equal to pi. Okay. So therefore, second root Z2 is equal to root 2 and cos negative pi over 3 plus pi plus I sine negative pi over 3 plus pi. Okay. So therefore Z2 is equal to root 2 and pi minus pi over 3 is 2 pi over 3. So cos 2 pi over 3, 2 pi over 3 is an angle from the second quadrant, so it will be a positive angle plus I sine 2 pi over 3. Okay. So this is the positive or the first root, not the positive thing. Yes, cos negative pi over 3 will be a positive number. It is in the fourth quadrant. The angle is in the fourth quadrant. So the positive or the real part will be a positive number. And this is the second root. Okay. Let Z1 and Z2 be the square roots of minus 1 minus root 3i, this one, where real part of Z1 is greater than 0. That means it will be a positive number and we have named the roots correctly. See, because cos of negative pi over 3 will be equal to cos of pi over 3, which will be equal to half. So the real part will be root 2 times half, which is root 2 over 2. So real part of Z1 is greater than 0. So this is Z1 and the other one is Z2. And let Z3 and Z4 be the square roots of negative 1 plus root 3ic. This one is the complex conjugate of this number, where real part of Z3 is greater than 0. Subpart B is saying expressing your answers in the form of Z equal to A plus BI, that is the Cartesian form, where E and B are real numbers. Subpart I is saying find Z1 and Z2. Okay, so because I can see the two roots over here, let me write the answer for subpart B over here. Z1 will be equal to root 2 times cos negative root 3 is equal to cos of pi, cos of negative pi over 3 is equal to cos of pi over 3, equal to half. So half plus I sine of negative pi over 3 is negative sine pi over 3, which is equal to negative root 3 over 2. Is equal to root 2 over 2 plus, or sorry, minus, it is root 6 over 2 I. Okay. And Z2 equal to root 2 again, and cos 2 pi over 3, this is an angle from the second quadrant where cos is negative, so this will be equal to negative half. And sine 2 pi over 3 again, this is an angle from the second quadrant where sine is positive, so it will be plus I root 3 over 2. So this is equal to root 2 over 2 plus root 6 over 2 I. Okay, this will be minus, yes. So these two are the two answers given in Cartesian form. I is saying deduce Z3 and Z4 because minus 1 plus root 3I is the complex conjugate of minus 1 minus root 3I. Therefore, Z3 and Z4, Z3 will be the complex conjugate of Z1 because Z1 is having the positive, the real part as a positive number, and Z3 is also having the real part as a positive number. So the Z3 will be the complex conjugate of Z1 and Z4 will be the complex conjugate of Z2. Okay, and this is carrying 4 marks and we are giving the 4 roots. So you do not have to explain anything. We can just directly give the 2 roots in Cartesian form, Z3 and Z4. Okay, and I Z3 is equal to root 2 over 2 plus root 6 over 2I, and Z4 equal to negative root 2 over 2 minus root 6 over 2I. Okay. Now, the 4 roots Z1, Z2, Z3 and Z4 are represented by the points A, B, C and D respectively on an Argand diagram. Subpart C is having 2 further subparts. I is saying plot the points A, B, C and D on an Argand diagram. Okay, fine. In order to plot these points on an Argand diagram, I will be preferring this representation instead of the Cartesian form. Okay, because over here I can see the angle, and if I draw a circle of radius root 2, I'll be just plotting the points according to the angle on the circumference of the circle. So whenever you have to plot the roots or any complex number, number of complex numbers on an Argand diagram, even if it is a single complex number, at least I prefer to plot it in the, not in the Cartesian form. Okay, it can be in the modulus argument form or in Euler's form, but I will not be preferring the complex number written in the Cartesian form because root 2, root 3, root 5, they are slightly difficult to plot. Okay, so this is the Argand diagram and I have plotted the 4 points A, B, C, and A. Of course, this circle is not required, but I have drawn the circle of radius root 2 so that I can plot the 4 roots on its circumference. Okay. And I have marked the points and which point is corresponding to which root. I have written the names and I have shown the angles also. Now coming to II, find the area of the polygon formed by these 4 points. Okay. Okay, so this is the polygon. In fact, this is a rectangle. We can see, and we have to find the area of this rectangle. So what we can do is, let me name this point as the central point as O. What we can do is, we can get the area of this triangle OAC and double it to get the area of the triangle OAC plus the area of the triangle OBD. And similarly, we can get the area of the triangle OBC and double it to get the area, sum total of the two areas, area of the triangle OBC and OAD. Okay. So, II, area of triangle OAC. And I'll be using the trigonometric formula for area of a triangle. The radius is root 2. So this will be equal to half times root 2 times root 2 times sine of, what is the included angle? This is pi over 3, negative pi over 3, because we have rotated the revolving ring in the clockwise direction. But actually the geometric angle is pi over 3 and this is also pi over 3. So the total angle is 2 pi over 3. Okay. And this and these two will be getting cancelled. So this is equal to sine 2 pi over 3 will be equal to root 3 over 2. Similarly, we have to get the area of the triangle OBC. So for this also it is half times square root of 2 times square root of 2 times sine of, what is the angle? See, this part is pi over 3 and this whole thing is 2 pi over 3. So this angle will be pi over 3. 2 pi over 3 minus pi over 3 is pi over 3. Okay. So this is also equal to root 3 over 2. So therefore, area of rectangle ABCD is equal to 4 times root 3 over 2, which is equal to 2 root 3 unit square. Okay. The 4 roots Z1, Z2, Z3 and Z4 satisfy the equation Z to the power of 4 plus 2 Z square plus 4 equal to 0. It is a quadratic equation and there are these 4 roots. Okay. The 4 roots 1 over Z1, 1 over Z2, 1 over Z3 and 1 over Z4 satisfy the equation P W to the power of 4 plus Q W square plus R equal to 0, where P, Q and R are integers. Subpart D is saying find the value of P, Q and R. Okay. Now, since these 4 roots, all of these are the solutions to this equation, I can take any of these 4 roots. Let me take Z1. So if I take Z1, it will be satisfying this equation. So this is subpart D. Since Z1 is a root of z to the power of 4 plus 2z squared plus 4 equal to 0. Therefore, z1 to the power of 4 plus 2z1 squared plus 4 is equal to 0. You can substitute z1 or z2 or z3 or z4. For each of these roots, the equation will get satisfied. Okay? So we are getting this equation. And now they are saying the four roots, 1 over z1, 1 over z2, 1 over z3 and 1 over z4 are the four roots of this equation. So for this equation, let me take 1 over z1 because I have taken z1 for this. So I am taking 1 over z1. I can take any of these four. So let me take 1 over z1 and let me substitute 1 over z1 in place of w. Also, since 1 over z1 is a root of pw to the power of 4 plus qw square plus r equal to 0. Therefore, p times 1 over z1 to the power of 4 plus q times 1 over z1 to the power of 2 plus r equal to 0. Okay. So, therefore, p times 1 over z1 to the power of 4 plus q times 1 over z1 square plus r equal to 0. And now I am multiplying the entire equation by z1 to the power of 4 to get rid of the denominators. So this is equal to p plus q z1 square plus r z1 to the power of 4 equal to 0. Now if I want to rewrite this equation in this form, because z1 to the power of 4 is the first term over here, let me rearrange the terms, or r times z1 to the power of 4 plus q times z1 square plus p equal to 0. This is the first equation and this is the second equation. Comparing the coefficients of z1 to the power of 4, z1 square and the constant term from 1 and 2, we get, see, r times z1 to the power of 4, and this is 1 times z1 to the power of 4. R equal to 1, then q is equal to 2 and p is equal to 4. Okay, let us write pqr. Therefore, p is equal to 4, q is equal to 2, r is equal to 1. The four roots 1 over z1, 1 over z2, 1 over z3, 1 over z4 are represented by the points E, F, G and H respectively on an Argand diagram. Support E, it is having two further supports. The support I is saying find 1 over z1 in the form z equal to a plus bi, where a and b are real numbers. Okay, and these are the four roots that we had found previously. So ei 1 over z1, so z1 is equal to root 2 over 2 minus root 6 over 2i. Okay, this one. Root 2 over 2 minus root 6 over 2i. So therefore, 1 over z1 will be equal to 1 over root 2 over 2 minus root 6 over 2i. And now we have to multiply with the complex conjugate. So it will be root 2 over 2 plus root 6 over 2i and root 2 over 2 plus root 6 over 2i. Okay, so this is equal to, the numerator will be root 2 over 2 plus root 6 over 2i divided by, this is 2, divided by, this is a minus b and this is a plus b. So it will be a square minus b square. So root 2 over 2 whole square and minus root 6 over 2i whole square. Okay, so this is equal to root 2 over 2 plus root 6 over 2i divided by root 2 square is 2 and 2 square is 4 and I square is minus 1, so minus of minus is plus. Root 6 square is 6 and 2 square is 4. So 2 plus 6 is 8, 8 over 4, so the denominator is 2. So this is equal to root 2 over 2 plus root 6 over 2 I divided by 2, which is equal to root 2 over 2 root 2. Sorry, 2 times 2 is 4, not root 2. Root 2 over 4 plus root 6 over 4i. Okay, so this is 1 over z1 in a plus bi form. Root 2 over 4 and root 6 over 4, these two are real numbers. I. Hence, deduce the area of the polygon formed by these 4 points. 1 over z1, 1 over z2, 1 over z3 and 1 over z4. Okay, so let me first of all, this is I and let me rewrite this 1 over z1 again. I just want to, because I'll be needing 4 points, therefore I just want to relate this one with the previously founded roots. Okay, 1 over z1, this can be written as, because these have the denominator of half, so I can write this as half times root 2 over 2 plus root 6 over 2i. Okay, so now coming to these 4 roots, you see z3 was equal to root 2 over 2 plus root 6 over 2i. So this is equal to half z3. Okay, and z3 was equal to, z3 was this point C. So it will be half of this, means the real part will be getting half and the imaginary part will also be getting half. So this is half of the real portion and half of the imaginary portion, maybe over here. Okay, and 1 over z1 is E. So this point is E. Okay. Similarly, if you see 1 over Z2, it is carrying 4 marks. So most probably this is carrying 2 and this is carrying 2. So I'm not asking you to do some elaborate calculation, but you have to do some calculation in case you do not understand the relation in just by looking at this, by inspection. 1 over Z2 will be equal to 1 over Z2 is this. So negative root 2 over 2 plus root 6 over 2I. And this should be multiplied by negative root 2 over 2. I have taken a different color just because I'll be plotting the points over here. So negative root 2 plus 2 and minus root 6 over 2 I. Negative root 2 over 2 minus root 6 over 2 I divided by negative root 2 over 2 minus root 6 over 2 I. So this is equal to, the numerator is negative root 2 over 2 minus root 6 over 2 I, and denominator will be a square minus b square. So minus root 2 over 2 whole square is, root 2 square is 2 and 2 square is 4, and this is plus root 6 square is 6, 2 square is 4. So again 2 plus 6 is 8, 8 over 4. The denominator will be 8 over 4, that is 2. So this is equal to negative root 2 over 4 minus root 6 over 4I. Again, this can be written as half negative root 2 over 2 minus root 6 over 2I. And you see, Z4 is negative root 2 over 2 minus root 6 over 2I. And which one is Z4? This point D. Okay. So half of this will be over here and half of this may be over here. Okay. And 1 over Z2 is F. So this point will be F. Now you have understood the pattern, and Z1, Z2, Z3 and Z4, these were the reflection of the Z1 and Z2 on the real axis. So this will be maybe this point, this is G, 1 over Z3, and this one is H, 1 over Z4. Okay. So again, because we have to get the area of the polygon, so we have to connect the 4 points. Again, this one is a rectangle, and we have to find the area of this rectangle. Okay. So area of rectangle this one is half, it was Z4. So area of rectangle, say E, H, F, G is equal to EH times EG. Okay. But we are seeing that EH is half of CB. This one is CB. So it is half of CB. So which is equal to half of CB times half of EG is what? CA. Okay. So this is equal to half times half of CB times CA. And CB times CA is the area of the rectangle ADBC, okay, equal to 1/4 area of rectangle ADBC, okay. And what was the area of the rectangle ADBC? It was 2√3 units square. So this is equal to 1/4 times 2√3. Therefore, this is because they have said that hence we have to use all the information that we have collected so far. Okay. So therefore, we will be using this. So this is equal to, therefore, area of the formed polygon is equal to √3/2 unit square. Okay. So we have completed solving this question and also solving all the questions of this paper. Thank you for staying with me till the end. Please like and share this video in case you have liked my explanation, and please do not forget to subscribe to my channel. Your liking, sharing and subscribing will be really helping me a lot. It will be motivating me. It will be telling the YouTube that my video is worth watching. So my video's reach will be increasing. So it will be helping me in numerous ways. We meet again very soon when we will be starting to solve a new paper. Till then, bye.